So I think thank you so much for having me here, and really appreciate how everything was pulled off for getting me here on this thing, and a really warm welcome for everyone who was listening there. I really wanted to cover something like on how we can build something like in a scalable fashion when we talk about CBDCs, and how we can have a way in which the liquidity fragmentation doesn't happen. So a little before I start and kickstart all those things, I just want to chat a little bit about who I am, where I'm working, and discuss a little bit more about me. Hello everyone, my name is Aishwar. Been working with Polygon for almost 2 years. Prior to this, I've been working at American Express, working in the Treasury Department, moving money across border for almost 3 years. And what I want to cover today is essentially like a way in which when we talk about blockchains and we talk about CBDCs, so how infrastructure can be built using public blockchains in a way where there's a huge amount of customization, where there is an ample amount of scalability, and also there is no way in which like the chains and the scalability is affecting the whole ecosystem in totality. So like if you talk about blockchains, if you talk the first name that comes to your mind is at least Ethereum. And we talk about Ethereum, there are three things which the blockchain trilemma covers. The first one is decentralization, security, and the third thing is scalability. And as for like the Vitalik quoted that there's no way today that we can actually go out and achieve all the three things on Ethereum. It might be there in the future, but currently it cannot happen. So what happened is like because of that, like Ethereum is like has two aspects with it, which is decentralization and security, but it is not scalable right now. But if you look at the ecosystem that Ethereum has versus our L1s which are there, so first of all, like if you look at security, Ethereum has been highly tested out. So it's much more secure that as compared to other L1s, based on the time it has been into the production, based on hacks that have happened on chains and everything like that. It is decentralized to that fashion that I can literally go out and start running a node on my side without using like any servers and everything like that. Then also like it has a huge amount of value stored on it. So as compared to some other chains. And then like when you talk about regulatory trust, there's a huge amount of trust on the chain, and time and again it has been proven. And also like when you look at any ecosystem, how it grows is it really grows how when there's a huge amount of developer ecosystem on that platform. So that's where like even on Ethereum, you have a huge amount of ecosystem of developers and everyone like that. And that is why like Ethereum is kind of a clear winner from that perspective. Like a lot of applications, I just try to put some of them here, but they're like multiples in and multiples of the applications which are there, which means that the like now if you're going out and launching something on Ethereum, you have more users because a lot of those users are using something or the other. The second thing is there's more liquidity, so it enables you to get your project adoption very quickly. That's why like a lot of projects want to go out and launch on Ethereum. But Ethereum is getting so much love, and it's something that it cannot handle it right. So that's where like essentially what happens is like the limitations kick in, where essentially when you talk about scalability, the demand for the network is much more higher. That's why like when there's a huge amount of demand on the network, the price for gas fees, or aka the transaction fees, is can reach up to $150 at times. Then when you talk about configuration, all the things are very rigid in that configuration style, cannot actually modify a lot of stuff from that perspective. And then when it comes to like compliance, also there's a lack of control over validators being decentralized. There's a lack of control over validators and people who are deploying contracts and everything. And when you look at a CBDC, essentially you want to have a network which is highly customizable, which can scale, and where you can go out and have a customized compliance so that it has all the necessary checks and balances when you actually want to go out and launch something. So that's where like the limitations come in, and that's where a lot of like layer twos, layer threes, and everything come and go out and connect with them. Now, when you talk about layer twos, there are three different types of layer twos which are there existing today. One is an optimistic rollup. Now, with optimistic rollup, the second one is deterministic rollup, and the third one is validium proofs. A very little like two-liner about each of them. Optimistic, when you do a particular transaction, essentially we optimistically assume that the transaction is correct. And because we assume that, essentially what happens is you're allowed to do the transactions on the L2, but when you try to withdraw your assets on L1, there is a challenge period for 7 days where essentially the transaction trail and everything can be verified and checked, like if there is anything which is wrong or something like that, that can be challenged. And if there is no challenge after 7 days, you can withdraw your assets. The second one is deterministic rollup. In deterministic rollup, what happens is everything that is happening, each and every transaction that is going on chain, all those things are actually going out and are being backed by math, which is somewhere what we call is that ZK math or moon math today. So that is where what happens is like you have a prover, and prover has a customized logic based on which it goes out and checks whether a transaction is valid or not. If the transaction is valid, it makes it move forward. If it is not, it rejects and does not generate proof. So that is the second type. And in this, what happens is because it's a roll-up, your data as well as the proof that is generated by the prover goes on top of Ethereum. The third one is Validium. Now in Validium, what happens is like essentially it remains as the same structure of deterministic, just that the data that you were sending along with proofs in deterministic rollups, here only what you do is you go out and you only send the proofs. Your the chain which is already there, so you create a data availability committee or a data chain where essentially you can go out and store the data. So that data is not going on Ethereum. Now, if you look at deterministic and Validium, what is the big key difference? Here on deterministic one, like all your data as well as proofs are going, so it is consuming more space on Ethereum. Hence, it is a little bit costly, but it is much more secure because like essentially everything that is happening here is getting recorded on Ethereum. So tomorrow, if something happens on your L2, you can actually go back to the L1, recover everything and come back. So that is where like this is there. But with Validiums, your only proof is going. So your Validium is as secure as your data availability committee is, or the data chain is. So these are the three ways in which like the whole scaling or the layer twos work. And with so many layer twos getting created, like if you look at the ecosystem today, what is happening is there are different types of L2s. They've chosen different types of architectures and infrastructures. So what has started to happen is like as today, there's a huge amount of fragmentation. So think about, let's say a chain which is available, but those users. So I'll give you an example. So for example, in Latin, there's a chain which was built by Nubank. Nubank has almost like 9.5 million active users on the chain. But because it is built as a separate L2, the users which are there cannot enter into like the other ecosystem or the main like other chains and everything. So that means those users are kind of fragmented and there's no direct quick link which is there. You can deploy bridges and everything like that. But yeah, so that's where you have fragmented ecosystems, you have fragmented liquidity, and hence it is very difficult to scale because essentially like you're working on one or two use cases and the whole ecosystem cannot get in to get you more users. So these are like the challenges today. And what I wanted to talk about is an infrastructure where what you can do is you can go out and create an ecosystem which goes out and enables you to have unlimited scaling and unified liquidity, interoperability, and a huge amount of customization that you can actually pull off. So that's where like Polygon CDK comes into the picture. Now, what exactly Polygon CDK or Chain Development Kit is and how does it fit the CBDC architecture is essentially where I want to go out and chat around this. So what CDK is, or the Chain Development Kit is, it goes out and gives you an architecture, which is essentially like I told you. So these are all deterministic and Validium proofs. So every chain, irrespective of how many chains you want to deploy, every chain has one prover. And that prover is common for all the chains. So it could be Polygon ZK AVM, it could be Polygon POS, it could be like C1, C2, n number of chains. But every chain has one prover, like the common prover. And the prover has the same logic, the ZK circuit logic, which is there. And you cannot go out and change that logic. Now, because you cannot go out and change that logic, irrespective of how many chains you want to go out and run this ecosystem on, the proofs that are getting generated with the same level of accuracy and on the same grounds. So if Polygon ZKVM is generating proofs, they are the proofs that are getting generated are coming out from the same logic. If chain C1 is running their own prover, their logic is also something which is exactly the same as the logic for the prover of Polygon ZK. So that way, what happens is the way the proofs are generated, the ZK circuits which are built, they are going out and enabling you to have just one single logic to go out and do that. And this is very powerful. Why this is very powerful is because what happens is, if you look at the ecosystem, so every chain is now generating proofs, and all the proofs that are getting generated out of this have the same logic, which means I can pick up the proof of generating from one chain. I can utilize that, and I can go back and put it somewhere, like utilize the assets from that chain and move those assets from one chain to another. So think of this scenario, like where the power of multiplication comes in. So let's say you have multiple banks running their own version of CBDC. So let's say Bank A wants certain aspects for their for their retail CBDC chain. Bank 2 wants something different. Bank 3 wants something different. They can have their customization levels on their own chains. And essentially what happens is the central bank which is there acts like a aggregator layer in between. And this aggregator layer, what it does is, so all the transactions that are coming in before you actually send those transactions back to Ethereum, which is, if you look at the down circle, this aggregator layer accumulates all the proofs from all the chains. Now, there are two reasons to do that. The first one is, if you directly go and send all the proofs to Ethereum, it is costly. And the second biggest advantage is, using the proofs that have been created and put on the aggregator layer, you can actually move assets between these chains in less than a minute. So within somewhere around 30 seconds to a minute, you can actually go out and move your asset from one bank to another in real time, from that perspective, from one bank to another and everything like that. And this aggregator layer is something where you can have the full overview from the central bank's perspective of where what asset is moving, who is doing what, and everything like that. So that way, and every bank can have like their own ways in which they want to create those chains. So they can customize like the throughput, how many transactions they want. They can go out and customize stuff from the perspective of like how private transactions they want to go out and have, and everything like that. So that way, what happens essentially is it ends up in this infrastructure where every bank has its own chain. Every bank can go out and generate a way in which they want to interact with CBDCs, and they want to distribute it to their customers. So similar, like today, you have bank account, and your bank accounts are with certain banks, and all the bank account holders of a certain bank have certain privileges which might not be true for some other bank. So every bank has their own way to do the business. Not every bank has the similar ways to do the business. So this is where you can go out and customize stuff. And even with all that customization, you can have an aggregator layer, which aggregator layer can enable you to go out and move assets from one bank to another, while the central bank can still be like in the phase of an aggregation, and they can have an overlook about what is happening where. They can have the accounting and everything like that in an open environment. And that is where, like, I think the current infrastructure which is there with the banking and the central banks and everything like that, this is the kind of model that can actually fit in without actually going out and changing everything. The like the questions that are asked, like whether the banks need to exist, whether the bank will be there in any way or not, and everything like that. So this way, the banks can coexist. The central bank can still have an overview, and this way you can have unlimited scalability, in the sense like since everyone has their own chains, they can have their own customizations and everything like that. So this is where like you can go out and create a way in which like the ecosystem is developed from the perspective of unlimited scaling, unified liquidity. You have interoperability between all the chains, and you can customize your chain based on the TPS compliance. And also like because this can be done in a Validium setup, you can have the data laws which are there in the country that to preserve the data, and within the jurisdictions and everything, you can actually go out and do those things. And the last part, which is like still very you can say kind of important, is essentially a fact that all the data that you have created is within the jurisdiction. Everything that you're putting here you can actually go out and all the proofs that you're putting on Ethereum. So if let's say the CBDC is like, oh, we do not want to go out and send the proofs on Ethereum, is there a way in which we can migrate from that and find out a way where we can settle proof somewhere else? Could be like a chain which is run by a central government as the point where all the proofs are getting settled. Is that a possibility? Again, the answer is yes. So you can have any fork of Ethereum or any get fork where you can actually go out and you can store those proofs separately without going into the public infrastructure. So this way, like, the whole infrastructure can be replicated in a private fashion with the checks and controls and compliances that could be there, without actually using any of these like exposures to cryptocurrencies and everything like that. So that is like how a CBDC, in my opinion, would be programmable, and you can actually go out and have these kinds of use cases. I think that's from my side. Happy to answer questions if any.
Amazing. Thank you. Can you hear me?
Yeah, I can.
Amazing. So great. Thank you so much.
No worries.
Now we have 10 minutes for questions, but I think you can say the question, and I think I have to repeat it probably so you can hear it because the microphone is here. So if anyone has any question, then please ask it, and I will repeat. Yeah. Okay.
Yeah, so I think it was a very good technical deep dive into how the process is going to work. What I'm more concerned about are the social elements of implementing CBDCs. I think we're looking at the general consensus, especially when we're looking at the average person, we need a little bit apprehensive on the long-term impact of CBDC and software and personal information. So from your perspective, what would you say to a novice who's thinking?
So I think I should repeat the question. So he's asking about the people might be worried about the social implications and the privacy implications. This is basically very impressive, efficient infrastructure, but how does how can you customize things like privacy, what data you can see and control? How do you kind of respect personal sovereignty and so can you say something about it?
Got it. I think from a privacy perspective, what we are trying to do is and this is something which we will launch this quarter, is something called shielded rollups. So shielded rollups. So I'll give you an example. Let's say BlackRock is there, and BlackRock has a product that they want to go out and distribute through their thousands of dealers that are there. Now, with BlackRock, every dealer that has an agreement, all those agreements would be completely different from each other. So BlackRock might have an agreement with party A or a dealer A for 2%, let's say, commission, or the second one could be 3% or something like that. And if this data becomes public, the biggest challenge for BlackRock is then everyone asks for the same or the best rates or the best terms and conditions. So with shielded rollups, what we're trying to go out and do is, it is trying to create shields between the party who is in between the transaction. So let's say if I and you, we want to do the transaction, essentially what will happen is only you and me, we can see the transaction because it is shielded, and only a proof of that goes on top of like the Ethereum or like a get fork which is there. And using that proof, you cannot actually go out and build the back end of the transaction, like who did the transaction, how did it happen, what were the terms and conditions and everything. So that is where I think privacy can be taken care of. That is one. The second thing is, one of the biggest challenges when we talk about creating a Web3 identity is, and the way identity works today. So today, like, let's say you want to go out and check in a restaurant or a hotel for some days or something, whatever, you actually have to produce original documents for which they usually go out and scan it and keep a copy with them, which is like the worst way to share your personal data, because you don't know where it is going to end up. With tools like Polygon ID, what you can actually do is you can create an on-chain identification through a Web3 address. How it works, let's say there's a KYC provider that is attached to your bank. Using the same data that has been provided to the KYC provider, what Polygon ID does it in a very layman terms, it will take your data, it will check whatever the data is required. It will delete all the original data, and it will just save a little bit credentials about yourself. So let's say it's to like the requirement is they want to check what is your age, what is your name, what is your nationality, and everything like that. Now what happens is you have a Web3 identity issue. For the restaurant, he doesn't know who you are. When you go there and you tell them this is my identification number, and restaurant wants to check whether you're 18 plus to live alone, or they want to check whether you are coming from a country where they are okay to give you a space or something like that, all they do is they go out and ping that question. And from the ID database, there's a yes or a no that comes in. So let's say the hotel has a condition that you can only come in if you're 18 plus. So what will happen is it will go out and put in the database, is this person 18 plus or not? If the answer comes as yes, you pass and you can go and live. If the answer comes as no, you cannot go and live. But it is not revealing what your actual age is. So that way you can have like Web3 identities on chain without revealing who you are, and being least, you can say, pervasive in your privacy while you're doing all these things on chain.
Thank you. Any more questions? Yeah.
What we Australia suggests is the predicted roadmap in terms of timelines for CBDCs and what some of the key milestones to look out for.
What are your predicted milestones for the CBDCs, and like what kind of predicted milestones do you see?
So can you repeat it? I couldn't get it.
So if you're what are the timelines for the CBDCs that you see, and like different technical milestones that you see basically in the rollout of CBDCs, basically?
Right. I think like working with some of the governments, not many, but some of the governments that I'm working with, all of them are seeing CBDCs in different fashion. Some of them want to like go out where the banking infrastructure is not very good anyways. So they want to go out and have one single CBDC rollout where essentially they bypass the banks. The banks are not that much needed, and they start having a central bank managing everything. Where you have well-established banks and banking systems and everything, there what people are trying to do is they're trying to go out and create interoperability between the banks, so that essentially banks still have the control, banks still exist. The manner in which they are there, they're still there. And just that, apart from that, there's just like a visibility perspective at how all these things sum up to the central government, and they have an ultimate control. So that is the second way. In the second way, also there are different ways in which like they are looking at CBDC, like from a perspective. So I can talk about some of the governments where I'm talking, where I'm working with. So one of the government is where they want to go out and they want to just create tools to enable CBDC. They do not want to run their own CBDC from a perspective of managing and seeing what exactly is customer behavior. So if you want to learn this, there is a very simple example: American Express and Visa and MasterCard. American Express runs everything in-house. So think about from a perspective of right from the start of when you swipe a card of American Express, the machines are there, the database is there, the calling system is there, everything is there. So what happens is American Express knows exactly your buying patterns, your purchasing patterns, your sales patterns, and everything like that, because 100% of the data is with them. But can an individual from the American Express side go into it and dabble and point out who you are? The answer is no. Everything is done through machine learning and everything like that. But because 100% data is in-house, they have much more visibility into the pattern of the consumer, not individual names, but the pattern of the card holder. If you talk about Visa and MasterCard are just networks. So they don't issue machines. They do not have like the telecommunication. They do the of their own and everything like that. Just a messaging network. Here, what happens is like, so this is the American Express is one model where you have everything in the visibility side. The other one is a Visa and MasterCard side, where all you're doing is you're just an enabler. So you're just a network where message authentication and everything is passing, but that's it. You do not have that much insight about customer behavior and everything, because that like you do not have all the necessary aspects to go out and articulate everything like that. So these are the ways in which like most of the CBDCs right now are being thought of.